Good morning to all. In this lecture, we are going to discussing about the least cost method to find the initial basic feasible solution for the transportation problem. Least cost method is more economical than the northwest corner method since it starts with a lower beginning cost. So let's see the general procedure for the least cost method. So that is the step 1 is the select the cell with the lower unit cost in the entire transportation table. Then after selection of the lowest unit cell, then step 2 is the allocate the maximum feasible quantity to the respected cell. Third step is eliminate the row or column where an allocation is made. Then fourth step is the repeat the procedure until the available supply at various sources and demand at various destination is satisfied. Now we will see the one example problem for the least cost method. Use least cost method to find initial basic feasible solution to the transportation problem using data of example as given in the table. So this is the transportation table. Here it is given the various origin and the various destinations and also given the supply and also demand respected origins and destinations. So now let's see the solution. First we have to check the given transportation problem is balanced or not. Here total demand is the 5 plus 8 plus 7 plus 14, that is the 34, and total supply is the 7 plus 9 plus 18, that is the 34. So here total supply equal to the total demand, then the given transportation problem is balanced. So now we will go for the least cost method. First step is the select the cell with the lowest cost in the entire transportation table. Here lowest cell unit cost is the 8 and respected cell is the S3 D2. So S3 and D2. So this cell is having the lowest unit cell value. Okay, so then after selection of the lowest cell unit cost, then we have to allocate the maximum feasible quantity to the cell. For this, observe the supply and the demand. Here supply is the 18 and the demand is the 8. So maximum units which can be allocated to the cell is 8. So we have to allocate the 8 units to the cell S3D2. So here we have to allocate the 8 units to the respected cell, that is the S3D2. Then after allocation of the unit in the respected cell, that is the S3D2, then we have to subtract the allocated value in the demand and the supply, that is the 8 minus 8, that is equal to 0, and 18 minus 8 equal to the 10. Next we have to eliminate the 0 demand column, that is the D2 column. So here we have to eliminate the D2 column. Next smallest unit transportation cost is 10. So in this cell is the S1 and the D4. So S1 row and the D4 column having the lowest unit cell cost. So here we have to select the S1 and the D4. And here I have to observe the supply is the 7 and the demand is the 14. Among these two, maximum allocation is possible 7 units. Then you have to allocate the 7 unit in the S1D4 cell. So in the S1D4 cell, we have to allocate the 7 units. Next, we have to subtract the 7 in supply and demand. That is the 7 minus 7 equal to 0 and 14 minus 7 equal to the 7. So here S1 row having the 0 supply units, then have to eliminate the S1 row. So next smallest cost is the 20 in the S3D4 cell. So in the S3 row and the D4 column having the lowest unit cell. So here we have next we have to select the S3 and D4 cell, that is the lowest cost of the 20. Here I have to observe the supply and the demand. Supply is the 10 and the demand is the 7. So maximum possibility of the allocation is 7 units. Then we have to allocate the 7 units in the S3D4 cell. Then we have to subtract the 7 units in the supply as well as the demand, that is the 10 minus 7 equal to the 3 and 7 minus 7 equal to the 0. Here column D4 having the 0 supply, then we have to remove the column D4. Next smallest value is the 40 for the S2 D3 cell and S3 D1 cell. So next smallest cost is the not unique. So that is there are two cells. One is the S2 D3 cell and S3 D1 cell that are having the same unit transportation cost of the 40. So in this situation, we have to observe the demand and supply for the respected cells. Here, demand and supply for the S2 D3 cell is the 7 and 9. And similarly for the S3 D1 cell is the demand and supply is the 5 and 3. So among these two cells, maximum allocation is possible with the S2 D3 cell. That maximum allocation is the 7 when compared to the cell S3 D1. So here we have to allocate the 7 units for the S2 D3 cell. And also have to subtract the 7 units in the demand as well as 7 units in the supply. That is the 7 minus 7 equal to 0 and 9 minus 7 equal to 2. Here D3 column having the 0 units of the demand. So we have to eliminate the D3 column. So next to lowest cost cell is the S3 D1 cell. So with the 3 units of the supply and 5 units of the demand. So we have to allocate the 3 units in the S3 D1 cell. And similarly we have to subtract the 3 units in the demand as well as supply. That is the 3 minus 3 equal to 0 and 5 minus 3 equal to the 2. Then we have to remove the S3 row. So here next remaining unit cell is the S2 D1 cell with the unit cost of the 70 and supply and demand both are the 2 units. So here I have to allocate the 2 units to the S2 D1 cell and remove the S2 D1 cell. So this is the transportation table with the allocated units. So then we have to calculate the total transportation cost of the initial solution by the least cost method. That is the total cost equal to the 7 units of the allocation and the transportation cost is 70. So 7 into 10 plus 2 into 70 plus 7 into 40 plus 3 into 40 plus 8 into 8 plus 7 into 20. So then the total transportation cost will become the rupees 814. This is the solution. So thank you.